Alright, so in this problem, I have 2 to the power of x squared over 4 to the power of x is equal to 16. Now, I'm going to rewrite this as 2 to the power of x squared over 2 squared to the power of x is equal to 2 to the power of 4. So this way, all my terms have a base of 2. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is 2x. So now I have 2 to the power of x squared over 2 to the power of 2x is equal to 2 to the power of 4. Now, if I have something from a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So now I have 2 to the power of x squared minus 2x is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x squared minus 2x, which is m, is equal to 4. So I have x squared minus 2x is equal to 4. And to solve this, I'm going to subtract 4 on both sides. So these two cancel out. Now I have x squared minus 2x minus 4 is equal to 0. Now to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, b is negative 2, a is 1, and c is negative 4. So I have x is equal to negative negative 2 plus or minus the square root of b squared, so negative 2 squared minus 4 times a, which is 1, times c, which is negative 4. And I have all of this over 2a, so 2 times 1. Now this is equal to 2 plus or minus the square root of negative 2 squared is 4, minus negative 4 times negative 4 is positive 16 over 2. So now this is equal to 2 plus or minus the square root of 20 over 2. And the square root of 20, that's the same thing as 2 root 5. So now this is simplified into 1 plus or minus the square root of 5. Alright, so in this problem, I have m to the power of 9 plus m to the power of 6 is equal to 36. So I'm going to first rewrite m to the power of 9 as m to the power of 3 to the power of 3. And rewrite m to the power of 6 as m to the power of 3 to the power of 2. And this is equal to 36. Now I'm going to let m to the power of 3 equal to the variable t. So now I have t to the power of 3 plus t squared is equal to 36. Now if I subtract 36 on both sides, these two cancel out, and now I have t to the power of 3 plus t squared minus 36 is equal to 0. So now to solve this, I'm just going to start, I actually need to find one value of t to find the rest. So to do that, I'm just going to start plugging in values. So if I plugged in 0 here, that would just be negative 36. If I plugged in 1, that wouldn't work. 2, that would be 2 to the power of 3, which is 8, plus 2 squared, which is 4, minus 36, which would not work. 3, that would be 27 plus 9 minus 36, which would work because 27 plus 9 is 36. So I have 36 minus 36 is 0, which is right. So t equals 3. That's the value. That's one value of t. So now that we have that value, we can find the rest of the values. So what I'm going to do is, from here, I'm going to rewrite this as t to the power of 3 minus 3t squared plus 4t squared minus 36 is equal to 0. And now, if I factor out t squared from t to the power of 3 minus 3t squared, I get t squared times t minus 3 plus, now I have 4 times t squared minus 9. Now, this is the same thing as t squared times t minus 3 plus 4 times t plus 3 times t minus 3 is equal to 0. Now, if I factor out t minus 3, I get t minus 3 times t squared plus 4t plus 12 is equal to 0. So now this gives me two equations. I have t minus 3 is equal to 0, meaning t is 3, and t squared plus 4t plus 12 is equal to 0. And this is actually going to be result in no solutions. So t equals 3 is my only value. And remember how we set m to the power of 3 equal t. So if m to the power of 3 is equal to 3, this means that m is equal to the cube root of 3. Alright, so in this problem, I have x to the power of 2 over 3 is equal to 16. So I obviously want to find the value of x here. So for my solution, I'm going to rewrite this, I'm actually going to take the power of 3 over 2 on both sides. And the reason I did this was because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And we want to find a value that when multiplied by 2 over 3 is equal to 1, because we obviously just want to find the value of x, and x is the same thing as x to the power of 1. So we want to make this 2 over 3 into a 1, and to do that, we need to multiply it with another number to make it 1. So that's why I multiplied it with 3 over 2, because if you multiply 2 over 3, 3 over 2, these two are reciprocals, so they make 1. So now, because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, x to the power of 2 over 3 to the power of 3 over 2, that's x to the power of 2 over 3 times 3 over 2, which is simply 1, and this is equal to 16 to the power of 3 over 2. So I have x equals 16 to the power of 3 over 2, and we actually have to simplify this a little bit. So 16 to the power of 3 over 2, well, 16 is the same thing as 4 squared. So now I have 4 squared to the power of 3 over 2. And remember, if I have something in the form a to the power of m to the power of n, that's equal to a to the power of m times n. So this is equal to 4 to the power of 2 times 3 over 2. Now these 2's can simply cancel out. So now I have x is equal to 4 to the power of 3. Now 4, that's the same thing as 2 squared. So now I have x is equal to 2 squared to the power of 3. 2 to the power of 3, 2 times 3 is 6. So I have x is equal to 2 to the power of 6. And this is the same thing as 2 to the power of 3 squared, right? 2 to the power of 3 is 8. So now I have 8 squared, which is equal to 64. So x is equal to 64. And that is my answer.